There's a moment every morning in Australia when millions of people reach for a punnet of blueberries, never questioning how those tiny, perfectly uniform spheres made it from muddy field to pristine supermarket shelf. But behind that simple act lies one of the most sophisticated technological operations in modern agriculture. Deep in the heart of Australia's berry belt, where the air smells of eucalyptus and fresh soil, a revolution is happening inside facilities that most people will never see. These aren't just packing sheds, they're precision laboratories where artificial intelligence makes split-second decisions, where robotic systems handle fruit more gently than human hands ever could, and where a single blueberry's journey is tracked with the same intensity as a diamond moving through a secure facility. The stakes are enormous. A single damaged berry can spoil an entire container during the long journey to international markets. One miscalculated sort can cost a farm hundreds of thousands of dollars. And in an industry where consumers demand perfection, where a berry's colour must match within microscopically precise parameters, where firmness is measured in units most people have never heard of, there's no room for error. What you're about to witness is the hidden world of industrial fruit sorting, where nature meets cutting-edge technology, where the humble blueberry becomes the subject of scientific scrutiny that would make a forensics lab jealous. This is the story of how Australia transformed a delicate, perishable fruit into a global export powerhouse, one berry at a time. The Australian blueberry industry operates on a scale that defies imagination. Every single day during peak harvest season, which runs from September through April, these high-tech facilities process between 15 and 30 tons of blueberries. That translates to roughly 3 to 6 million individual berries passing through sorting systems in just 24 hours. But here's what makes this truly remarkable. The entire journey from field to final package happens within a maximum of 4 hours. This isn't just impressive logistics, it's a biological necessity. Blueberries are what industry experts call non-climacteric fruit, meaning they don't continue to ripen after harvest. The moment a berry is picked, a countdown begins. Enzymatic processes start breaking down cell walls. Moisture begins to evaporate. The delicate bloom, that silvery white coating that signals freshness, starts to deteriorate. Australian facilities have become world leaders in preserving what's called post-harvest quality through a combination of temperature control and speed that borders on obsessive. The technology inside these facilities reads like science fiction. Modern Australian blueberry sorting lines employ hyperspectral imaging cameras that don't just see the surface of a berry. They penetrate beneath the skin, analysing the internal structure, detecting hidden defects that human eyes could never spot. These cameras capture images across more than 100 different wavelengths of light, from ultraviolet to near-infrared. Each wavelength reveals different information. Some show surface blemishes. Others detect internal bruising. Still others identify sugar content, firmness, and even predict how long the berry will remain fresh. The system processes this ocean of data in milliseconds, making accept or reject decisions faster than a human neuron can fire. But here's the truly mind-bending part. The artificial intelligence running these systems learns. Every berry that passes through teaches the system something new. Over time, the AI becomes more accurate than any human sorter could ever be, identifying patterns and correlations that exist beyond human perception. Australia's geographic isolation has forced its blueberry industry to innovate in ways that producers in other countries never had to consider. When your nearest major export market is thousands of kilometers across open ocean, when berries must survive weeks in shipping containers, when a single failed shipment can bankrupt a small farm, you develop technologies that push the absolute limits of what's possible. Australian engineers have pioneered sorting systems that can detect the microscopic differences between a berry that will last 3 weeks and one that will spoil in 10 days. They've developed proprietary algorithms that predict shelf life with 87% accuracy based on nothing more than optical analysis. These innovations didn't come from agricultural research institutes or university laboratories. They came from desperate farmers and ambitious engineers working together in corrugated metal sheds, trying to solve an impossible problem. How do you compete in global markets when you're literally on the opposite side of the planet from your customers? The economics of blueberry sorting reveal why this technology matters so much. A premium grade blueberry destined for fresh export markets in Asia or the Middle East sells for approximately 35 to 45 Australian dollars per kilogram at wholesale. A second grade berry, identical in almost every way except for minor cosmetic imperfections, sells for $12 to $18 per kilogram. A third grade berry goes to processing facilities for juice or frozen products at $3 to $5 per kilogram. The difference between these grades often comes down to measurements smaller than a millimeter, color variations invisible to casual observers, or firmness differences that require laboratory equipment to detect. A sorting facility that can accurately separate these grades, that can maximize the percentage of fruit reaching premium markets, can mean the difference between a farm thriving or going under. This is why Australian facilities have invested millions in technology that most people will never see. Why they obsess over details that seem absurdly minor. Why they treat each berry with the care usually reserved for precious gems. The seasonal nature of blueberry production creates its own unique pressures. Unlike manufacturing facilities that run year-round, these high-tech sorting operations must be designed to handle massive volume for 6 to 8 months, then sit largely idle for the rest of the year. The equipment must be robust enough to process millions of berries daily, yet precise enough to handle each one as if it were the only one that mattered. Australian facilities have pioneered modular designs that allow them to scale capacity up or down based on daily harvest volumes, which can vary by 300% depending on weather conditions, varietal ripening schedules, and market demand. On peak days, a single facility might run 3 shifts around the clock, with technicians constantly monitoring and adjusting systems to maintain quality standards that never waver regardless of volume. Here's something that surprises even industry insiders. The blueberry sorting process actually improves fruit quality in ways that seem counterintuitive. When berries arrive at the facility, they're often at slightly different temperatures, having been picked at different times of day from different parts of the farm. The sorting process includes a rapid cooling phase that brings all fruit to a uniform 4 degrees Celsius within minutes. This sudden temperature drop, when done correctly, actually triggers beneficial physiological responses in the berry. Cell membranes stabilize, respiration rates drop, enzymatic activity slows dramatically. The result is fruit that's actually in better condition after sorting than it was when it arrived, a phenomenon that Australian researchers discovered accidentally and have since refined into standard practice. This discovery alone has extended the viable export window for Australian blueberries by an estimated 7 to 10 days, opening markets that were previously unreachable. The raw materials that feed these high-tech facilities begin their journey in carefully managed fields where every variable is controlled with scientific precision. Australian blueberry farms operate more like outdoor laboratories than the traditional agriculture. The berries grow in specially formulated soil mixes, typically composed of composted pine bark, peat moss, and perlite, with pH levels maintained between 4.5 and 5.5. This acidic environment is crucial because blueberries are one of the few commercial crops that require such conditions. The plants receive water through drip irrigation systems monitored by soil moisture sensors that communicate with central computers, ensuring each plant receives exactly the amount of water it needs, no more, no less. Fertilization happens through the irrigation system itself, a process called fertigation, where nutrients are delivered in precise ratios calculated to maximize fruit quality rather than just yield. Australian growers learned decades ago that the biggest berries aren't always the best berries. Instead, they optimize for firmness, flavor intensity, and post-harvest longevity, qualities that matter far more in export markets. Harvest happens in the pre-dawn darkness when temperatures are coolest and berries are at their firmest. Picking crews, many of whom return to the same farms year after year, move through rows with practiced efficiency. Each picker carries a specialized bucket with a soft foam lining that prevents bruising. They're trained to use a gentle rolling motion when removing berries from the stem, a technique that leaves the picking scar. the small area where the berry attached to the plant, as small as possible. A large picking scar creates an entry point for bacteria and accelerates spoilage. The best pickers can harvest 20 to 30 kilograms per hour, while maintaining quality standards that reject any berry showing the slightest defect. These berries are placed into shallow trays, never more than 3 layers deep, to prevent the weight of upper berries from crushing those below. Within minutes of picking, these trays are loaded onto refrigerated trucks for the short journey to the sorting facility. The moment those trucks arrive at the facility, the high-tech process begins. Berries are gently transferred onto a receiving line where the first stage of sorting happens through simple physics. A series of vibrating screens separate out leaves, stems, and any undersized berries that slip through field quality control. The vibration frequency is carefully calibrated. Too gentle, and debris remains mixed with fruit. Too aggressive, and you damage the berries themselves. Australian facilities typically operate these screens at frequencies between 28 and 32 Hz, a range determined through years of trial and error. The berries then pass through an air classification system, essentially a controlled wind tunnel where lightweight debris is blown away while the heavier berries continue forward. This airflow is precisely regulated because blueberries, despite their small size, vary significantly in density. A firm, fresh berry is noticeably heavier than one that's begun to dehydrate or deteriorate internally. Next comes the first camera inspection station. Here, high-resolution optical systems capture images of every berry from multiple angles as they pass by on specialized conveyor belts. These aren't ordinary conveyor belts. They're made from food-grade materials with carefully designed surface textures that keep berries separated and oriented properly for imaging. The belt moves at exactly 1.2 meters per second, a speed that balances throughput with image quality. Any faster and the cameras can't capture sufficient detail. Any slower and the facility can't process enough volume to remain economically viable. The cameras themselves are engineering marvels. They capture images at resolutions high enough to detect defects smaller than 0.5 millimeter. They operate in environmentally controlled housings that maintain constant temperature and humidity because even slight variations can affect image quality and, consequently, sorting accuracy. The data from these cameras feeds into processing computers running proprietary artificial intelligence algorithms. These systems evaluate each berry across dozens of parameters simultaneously. Size is measured in 3 dimensions with sub-millimeter accuracy. Color is analyzed not just as a single value, but as a distribution across the berry surface, identifying berries with uneven ripening or discoloration. Shape is assessed to identify berries that are misshapen, which often indicates growing stress or genetic issues. Surface defects, from tiny scars to insect damage to fungal infections in their earliest stages, are identified and catalogued. The system even evaluates the bloom, that delicate silvery coating, using specialized lighting that makes it visible to cameras. All of this analysis happens in less than 1/10 of a second per berry. Based on this analysis, berries are sorted into multiple grades using a system of precisely controlled air jets. As each berry reaches a specific point on the conveyor, a burst of compressed air, lasting just 20 milliseconds, diverts it into the appropriate collection channel. The timing must be perfect. Fire the air jet too early or too late, even by a few milliseconds, and the berry ends up in the wrong grade. Australian facilities use pneumatic systems capable of firing up to 200 individual air jets per second, each one independently controlled based on real-time decisions from the AI system. The air pressure is calibrated to be strong enough to reliably divert berries, but gentle enough not to damage them. This balance point varies depending on berry size and firmness, so the system constantly adjusts pressure based on feedback from the sorting results. Premium-grade berries, those destined for high-end fresh markets, undergo additional scrutiny. They pass through a second imaging station equipped with even more sophisticated technology. This station uses near-infrared spectroscopy to analyze the internal structure of each berry without damaging it. The system can detect internal bruising, hollow centers, and even measure sugar content and acidity levels. This non-destructive testing was adapted from technology originally developed for medical imaging, and Australian facilities were among the first in the world to apply it to fruit sorting. The investment in this technology is substantial, with individual units costing upward of $500,000 Australian dollars, but the return on investment comes from the ability to guarantee quality at a level that commands premium prices in international markets. After sorting, berries move to the packaging area where automation continues to dominate. Robotic systems gently transfer berries into consumer packages, typically plastic clamshells or punnets, using suction cups with pressure sensors that ensure they grip firmly enough to lift the berry but gently enough not to damage the delicate skin. These robots can package up to 60 punnets per minute, working with a consistency and gentleness that human packers struggle to match over long shifts. Each package is weighed to ensure it contains the precise amount specified, typically 125 grams or 250 grams, with tolerances of plus or minus 2 grams. Packages that fall outside this range are automatically rejected and resorted. Quality control happens continuously throughout the process. Random samples are pulled from each batch and subjected to destructive testing in an on-site laboratory. Technicians measure firmness using penetrometers that quantify the force required to compress the berry. They measure sugar content using refractometers that analyze juice samples. They conduct shelf life simulations, storing berries under various temperature and humidity conditions to predict how they'll perform during shipping and retail display. All of this data feeds back into the sorting system, allowing it to continuously refine its decision-making algorithms. If the lab discovers that berries sorted into premium grade aren't meeting quality standards, the system automatically adjusts its parameters to be more selective. The final stage before shipping involves rapid cooling. Packages are moved through a forced air cooling tunnel where cold air at precisely controlled temperature and humidity flows around each package. This brings the fruit temperature down to the optimal storage range of 0 to 2 degrees Celsius within 30 minutes. The speed of this cooling is critical. Too slow and quality deteriorates. Too fast and you risk causing cold injury, a type of damage that doesn't appear immediately but causes the berries to break down prematurely during storage. Australian facilities have pioneered cooling protocols that optimize this balance, using real-time temperature monitoring and variable fan speeds to ensure every package receives exactly the cooling profile it needs based on its initial temperature and the specific characteristics of the berries inside. Throughout this entire process, every package is tracked using barcodes or RFID tags that record exactly when and where the berries were picked, which sorting line they passed through, what grade they were assigned, and dozens of other data points. This traceability system allows facilities to track individual packages from farm to consumer, providing accountability and enabling rapid response if quality issues arise. If a retailer in Singapore reports a problem with a specific batch, the facility can identify within minutes exactly which field those berries came from, who picked them, when they were sorted, and what path they took through the facility. This level of traceability, once considered unnecessary overhead, has become essential in modern food safety protocols and has helped Australian blueberries build a reputation for reliability in international markets. The environmental control systems in these facilities rival those in pharmaceutical manufacturing. Temperature is maintained within a range of plus or minus 1 degree Celsius throughout the entire facility. Humidity is controlled to prevent both dehydration and condensation, typically maintained between 85 and 90% relative humidity. Air quality is managed through sophisticated filtration systems that remove dust, spores, and potential contaminants. The facilities operate under positive air pressure, meaning air constantly flows outward, preventing outside air and potential contaminants from entering. Even the lighting is carefully controlled, using wavelengths that don't accelerate fruit deterioration while providing sufficient illumination for both human workers and camera systems to operate effectively. The human element, despite all this automation, remains crucial. Skilled technicians monitor systems constantly, making micro adjustments based on experience and intuition that no algorithm can replicate. They watch for subtle changes in berry characteristics that might indicate issues in the field, allowing farms to respond quickly to problems. They maintain and calibrate the complex machinery, a task requiring expertise in mechanics, electronics, computer systems, and fruit biology. These technicians represent a new breed of agricultural worker, equally comfortable with wrenches and programming code, understanding both the biological needs of delicate fruit and the technical requirements of million-dollar sorting systems. So the next time you pick up a punnet of perfect Australian blueberries, remember the invisible journey those berries took. Remember the artificial intelligence that examined each one with superhuman precision. Remember the robotic systems that handled them more gently than human hands. Remember the engineers and technicians who designed and operate systems that turn agricultural production into high-tech manufacturing. Those perfect berries aren't an accident of nature. They're the result of one of the most sophisticated sorting operations in modern agriculture, a testament to what happens when innovation meets necessity, when technology serves biology, when an isolated nation decides that distance won't stop it from feeding the world. But speaking of iconic Australian foods that undergo remarkable transformations in high-tech facilities, have you ever wondered what really happens inside the factories that produce Australia's most divisive spread? That dark, mysterious paste that Australians swear by and the rest of the world can't quite understand. The video that just appeared on your screen takes you inside a high-tech Vegemite factory, where one of the world's most unusual food products is created through a process that's equal parts chemistry, microbiology, and industrial precision. You won't believe the science behind that distinctive taste, or the surprising origins of the key ingredient that makes it all possible. Click that video now to discover the secrets behind Australia's most controversial culinary export. And if you found this journey through blueberry sorting as fascinating as we did, hit that subscribe button so you never miss our deep dives into the hidden industrial processes that create everyday products. We'd love to hear from you in the comments. What surprised you most about how blueberries are sorted? Was it the artificial intelligence, the speed of the process, or something else entirely? Drop your thoughts below, and we'll see you in the next video where we uncover another hidden world of modern manufacturing.